Hello and welcome back to Math and Tea, the show where we talk math and drink tea. I'm your host, Professor Joseph Vandehei. In this episode, we're going back to talking about Professor Andrew Hacker and his critiques of math education policy. Hacker runs into the standard problem that most pundits do. If he's right and his ideas are correct, well, why aren't they being put into practice? There has to be some force out there in opposition to him. Now, to Hacker's complete and total credit, he does a good job of not falling into the trap of constantly trying to assign blame. He's more interested in trying to understand what the issues are and propose solutions for them. However, when he does want to assign blame, one of his favorite targets are what he calls math mandarins. To him, the mandarins are an elite group of theoretical mathematicians who can't be bothered to actually get into the trenches of teaching mathematics, and yet they exert a strong control over the K-12 education policy. And as an example of one of the mandarin's silly ideas, he goes to everyone's favorite math education punching bag, the new math. This is the one point where I think Hacker devolves into, shall we say, conspiracy theory, not least because he can't actually name a single one of these mandarins. In his book, he automatically assumes that any researcher who offers an opinion on math education policy must not actually be a good teacher, just because they do research. It's incredibly presumptuous of him. Now, don't get me wrong, I've known my fair share of mathematicians who think that teaching is a dismal chore, but they're disinterested, both in teaching and in teaching policy. And, in fact, his mention of the new math gives a great example of why his so-called mandarins don't have the control that he thinks they do. The new math was a math education reform policy from the 1960s that is most often remembered for expecting elementary school students to learn abstract concepts like set theory and Boolean logic, and it received a bunch of ridicule for emphasizing these concepts over more practical things. Now, if you haven't heard the Tom Lehrer song about the new math, stop what you're doing, pause the video, go listen to it right now. Don't worry, I'll wait. Done? Good. Now, having said all of that, most of the criticism of the new math forgets what the old math was and how and why we tried to change it. A lot of different issues all came to a head in the 1950s to pave the way for the new math. First, mathematicians and educators had started to work in separate spheres. It used to be that math teachers were people who specialized in mathematics without any special knowledge about education. But they started becoming people who specialized in understanding education without any special knowledge about mathematics. Advances in mathematics, simplifications in mathematics, which subjects were more or less useful in the modern era. None of these things were getting relayed to K-12 instructors. I saw one quip that said that the students of the 1950s were being prepared for the universities of the 1750s. At the same time, progressive education reforms from earlier decades were paring down education more and more to its barest essentials, and math was really not deemed all that essential. In 1952, 20 states required no high school math education whatsoever. 24 states only required 1 year. What little math there was largely rote memorization. It got so bad that even non-mathematical instructors were worried about the lack of math instruction. This was all combined with Cold War-era concerns that we Americans were falling behind the Soviets in terms of science and technology. This was especially bad because those disciplines in universities were having to educate their students for a year or sometimes more in basic arithmetic, algebra, and trigonometry before they could even begin teaching their own subject. It was a perfect storm. The public, the educators, the government, and the researchers all agreed that change was needed. But which change? As much as we like to think of the new math as one set of reforms, in fact it was a bunch of different sets of reforms, all heading towards the same goal. The biggest and most widespread changes came about because the federal government tapped one particular researcher to enact their ideas that involved taking in a lot more input from theoretical mathematicians. And this is what resulted in so much of the abstraction that the new math gets criticized for. While many people think of the new math as complete and total failure, in fact it left two large and enduring legacies in American education. First, it de-emphasized rote memorization and put an emphasis back on understanding what's going on behind the rules. Those abstract concepts, they were trying to get at that understanding, well-intentioned but poorly executed. It's kind of a wonder that Hacker, with his emphasis on numeracy, doesn't like the new math more. Second, the new math changed the focus of mathematics education, especially in high school, to be preparing students for college. Maybe that's why Hacker doesn't like it so much. Anyway, the point is not the legacy of the new math, but how it came to be. It wasn't the result of a couple of elite mandarins deciding to dabble in affairs beyond their understanding. It was the combined effort of almost our entire society. Really, any large and sudden change in curricula is hard to accomplish. Most changes are slow and gradual and the result of dozens of competing influences. As an example, many high school and elementary school teachers are unlikely to wing big changes in their classes without a textbook to back them up. They just don't have the time to craft all the lessons and the quizzes and the homework. But at the same time, textbook companies aren't likely to make big changes either. Crafting a textbook is a long, arduous, and expensive process. If they go through the whole process and there's no one there to buy the textbook, they just wasted a whole lot of money. Changes have happened, though, slowly but surely. The advent of calculators, computers, the internet, have all changed the way that textbooks expect students to learn math. I remember my parents telling me about their calculus classes. They told me they had to memorize dozens upon dozens of integral formulas. I had to memorize maybe 10. At the same time, everyone is playing the expectations game. You can't change the elementary school curriculum too much because high schools are expecting elementary school students to be taught certain things. If you want to make a big change at the elementary school level, you need to make a big change at the high school level too. And the same between high school and undergraduate level. We can't even change certain undergraduate subjects like Calc 1 or Calc 2 too much because other subjects rely on them. In fact, about the only place I know of where it's easy to change the curriculum is grad school. Because if you want to change what, say, a number theory course is about, the only people who are really going to be worried about that are maybe a couple other number theorists in the department. And let's not forget how much power you have in all of this. That's right, you. Don't forget, most decisions at the K through 12 level are made by local school boards or by the state government, and all of those decisions are going to be made with you, average citizen, in mind. Just look at the Common Core standards. They're about as stripped down a curriculum as you could make. They hardly even count as a curriculum, actually. They enjoy large support from educators and, so far as I'm aware, from mathematicians as well. But they got a lot of pushback from the public and from political bodies. They got through, but it was no easy task. In other words, changing math education policy is, well, hard. The new math was a flash-in-the-pan movement caused by basically everyone wanting basically the same thing, and it doesn't really represent how much influence mathematicians actually have over math education policy. There's a lot of things we'd want to change if we actually had the political capital to do it. I'll talk about what some of those changes actually are next time, but that's all for now because I'm out of tea again.